So in particular, we'll be looking at a couple of cases. So one is what is the equals method and when and how do we use it. And the other one is this comparator and comparable. Uh, so one of them is an interface. So how do you again, or what is the reason for using this and how do you use it? And the last one is what is called as cloning. So it should be a single. And, right. Okay. So let's get started. Okay. So so these are again some motivating examples, but so can you spot any similarity among these three things? So one is a cat, the other one is this like a galaxy kind of, right? And the third one is some furniture, dining table, right? And I mean you also have, yeah, basically some furniture. So um, so based on these pictures, do you notice any similarity between these three? So I will give a minute, but yeah, you can also unmute and let me know. Right. So it's hard to find some similarity, right, between all these three. So um, let's look at it from the point of view of the class. So you have a cat class that has the name and the breed, and the universe class that will have the list of stars, and then the furniture class that has a list of okay, these again a typing mistake, right? So this should have been, let's say, a list of chairs, for example. Right now, so if you look at it from the class point of view, then again the question is, do you see any similarities? Which is again hard to spot. Right? So I don't think there are any similarities even if you look at it from the code point of view. But there is some class that is implicit for all of them. So it's like the parent class for all of them. And that is what is called as the object class. So this happens by default, right? So this is like the parent for all the classes. So even though you don't explicitly extend object, by default every class extends object. So object is a superclass for all the classes that you create, right? So let's say that also applies to the class where you are extending other class. So let's say furniture is extending the wood class. Wood class extends object class. So in that sense, they are related because now, so everything belongs to, so object is like the God class, so to say. So everything comes under it. So everything is like a subclass for the object. And so in some ways you can say that, so if you go back to the set theory, right? So I don't, maybe set discussed already for you? Like, did it come across in some other lecture or course? And one of you can unmute and let me know. No. Okay. So
Yes, sir. Yes.
oh, you had sets. Okay. Okay. So in sets you have this universal set, right? Like it's represented by u or mu, and universal set is supposed to contain all the sets. So you can treat this as the universal set. So there's a class called object, and now that's the universal set. So it encapsulates every other class that you ever define or create. So in that sense, they are similar. So you have cat, universe, and furniture, and they all by default extend this object class. And that's the connection that we are trying to show from these pictures, right? Although they are unrelated, they are related through this object class. So this forms the root for all the classes, and like I said, and it's the superclass for every other class that you create. And you don't, I mean, this comes in by default, so you don't have to say extends object. It's already extended by default. And with that comes a few methods that you can make use of. So object has these methods, so equals, clone, finalize, and so on. And we'll be looking at a few of these methods in this particular topic, right? So the ones that is of interest is highlighted in blue, right? So we'll be looking at say equals, clone, and toString. So let's start with the toString. And so this one is implicit. So let's say you define a cat class. So all these methods, since object is inherited by default, all these methods are also accessible by cat. So in that sense, whatever class you create, all of them will have all these methods. So and that's why you see, so whenever, let's say in the IDE Eclipse, when you try to call a method, say there's a cat called cat's instance called I, right? So now if you say I dot, all these methods will show up, even though you did not define it within the cat, right? Because they have been inherited from the object. Okay. So now let's start with toString. So the purpose of toString is to have a textual representation for the state of the object. So it's basically a human readable representation for the state, right? So let's say the cat has two instance variables. One is the breed and the other one is the color. So if you can have a human readable representation of the state of the object, then that is the whole point of toString. So that the idea is you can print it and get to know the state. But apart from that, there are all these classes, all these methods which are part of the object class, and all these are inherited by default, right, to any of the classes. So we'll briefly look at these, the functionality for each one of them, but as we go over this lecture and rest of the lectures, right, so you will get to know about all these classes or all these methods. So the first one is clone. Clone is used to create a copy of the object. So by copy, we mean the copying of the state, right? So you will create another object which has the same state of the object that you would like to be copied from. Again, like we'll get to know this later on, but it is used to create a copy. So the second method is equals. So it is, as the name says, it will check whether the object on which you are calling the equals is same as the one that you passed as a parameter. So it returns whether, it returns a Boolean type, and it returns whether this given object O is same as the object that you used to call the equals method. The next one is finalize. This is related to garbage collection. So when we discuss garbage collection, we'll also get to know more about finalize. And the next one is called get class. So this returns the type of the class, type of the object, right? So for example, if you say cat C, and you can say C dot get class. So class always returns the type of this object, right? So it will say it's a cat. All right. So that's the point of this get class. And the next one is hash code. So again, as the name says, it will return the hash of this object. So that's mostly calculated based on the state of the object. And you can use this for, let's say now you want to store this object in a hash map, right? And the way to do that is through this hash code. So it will make use of this hash code and it will store this object in the hash map. And the next one is toString, which we already discussed. So toString is used for getting the human readable form of the object's state. So it's a textual representation. And there are a couple of other classes, which is notify all, wait, and wait with some parameters. So all these four methods are related to threads, right? Concurrency and threads and locking. So which we'll see, which we'll be going over them at a later point of time. So these are all the methods that come with the object, and when you inherit the object, you will get access to all these methods.
So small question, what do you mean by finalize method in the previous slide? Like I did not get that.
Yes. So finalize is related to what is called as garbage collection. Right? So garbage collection is, let's say in your C, you can say delete. You can say, you can ask for memory and then you can free up the memory, right? So in C++, you also have free, for example, you have malloc and you have free and delete, right? So you can use these methods to give back the memory that you have requested for some time back. Now, that possibility doesn't exist with Java. So you cannot explicitly say do a delete or a free. So it has to be done automatically by what is called as a garbage collector. So that takes care, so it gets invoked every now and then it will try to reclaim some memory from your application, right? So whenever garbage collection starts, you can, um, so it will also call the finalize. So if you have a finalize defined in your class, it can call it, but that's optional, right? Because there's already a default implementation provided by object. So this is, in that sense, it's related to garbage collection. So that's why I said we'll get back to this whenever we discuss garbage collection. Right. So did that answer your question?
So, sir, these methods are invoked without us mentioning them, or we should mention them very, very much. I think in an earlier lecture you mentioned a public string to string is like automatically already this
Oh,
method is already
right. Okay.
put in,
Yeah.
right?
So that it's called automatically if it's part of, let's say, some println method, right? So you have system.out.println, and you said, um, say the instance of cat is C. So you are saying that system.out.println of C. So then it automatically calls toString. So C.toString. That's implicit, because println needs something to print, which is a text, and you cannot print the object itself. So there has to be some mechanism to convert the state of the object to the string, and that's why toString gets called automatically. Again, it's the same case with. So yeah, that's right. So even with finalize, you don't explicitly, generally you don't explicitly call it. It's called automatically by the garbage collector, right? And again, it's the same with hash code, for example. So if you are storing your object in the hash map, hash code is used, and then it will generate the code, and depending on the code, it will place it in one of the buckets in the hash map, right? Or one of the slots in the hash map. So, but there are methods that you call explicitly. For example, you can call wait explicitly, and you can call notify also explicitly. But yeah, we'll be looking at them later on when we discuss threads. Right?
Yes,
Did that
sir.
answer your question? Yes.
So whenever I hover over an object, it always shows me hash code option. So is that
Right.
the same thing as hash code you choose, you like seeing on the slide?
Yes. Yes. Yeah, it's the same. So whenever you say cat c dot, and then you'll get some method suggestions, and all these methods will show up, right? And yeah, so all these methods, like I said, they come from the object class. You
But
get,
hash code only gets invoked when you're making a hash map, or it can get invoked by any object.
no, you can also directly invoke it. You can say c dot hash code, and it will return an integer. And if you want to make use of it in some way, you can do so.
So it will assign a code to that object where which is a unique code, and we can just use that code to refer to an object. I'm not
Yes,
understanding
yes,
what
yes.
hash code actually does.
So let's say, okay, so let's say you are creating a hash map. Um, yeah, since you have uh, DSA, I think you hash map has been discussed at some point, right?
Yeah. Yeah.
Okay, so in hash maps, you have a set of slots, and there's a key and a value, and the key is always unique, right? The value, and you associate, you retrieve, you put in values inside the hash map using the key again, and you retrieve it using the key.
Mm.
Um, so let's say instead of having hash map of default data types, which is the int, float, and so on, you have the hash map of say cat. So for example, you want to say that every pet shop, for every pet shop, you want to capture the groomer. I'm just giving one example. So let's say pet shop is the key, or instance of pet shop is the key, and instance of groomer is the value. So in this case, there has to be a mechanism to figure out to which slot in the hash map this particular instance should go to, right? So in order to figure that out, it needs a hash code, and this is the method that computes it. So you can, again, at this, you don't have to again explicitly call hash code. You can simply say, let's say in Java you use the put method, for example, right? So you can say hash map dot put of key comma value. So you can say hash map dot put of p comma g. P is the instance of pet shop, g is the instance of groomer. So you can simply say p dot g, sorry, p comma g. But internally, it's like saying p dot hash code comma g, for example. So it will find the hash code, then based on the hash code, it will find the slot.
So, sir, if we have put that p comma g in hash map, so if we call p dot hash code, it will give me the hash code which has assigned, right?
Yes, yeah.
But sir, if I don't make any hash map, then also I can call the hash or
yeah,
hash.
you can call it, yeah, this is a public method, right? You can call it.
There is no reason for a hash code. I mean, if I call it, but then there will be no meaning attached to it, right?
Yes, yes.
Code will have no meaning.
Yes, I mean, yeah, it will return the code, but I mean, yeah, if you don't have any utility for that code, then there's no point in calling it.
Okay. Thank you, sir.
Yes. Yeah, are there any other questions?
Can you explain the get class method?
Sorry, what's that? Get class. Okay, get class. Yeah, so obviously, I mean, all these methods, the way to invoke it is through the object. Right? So let's say you have cat c, and then you can say c dot get class. So that will return the class of that c, the instance. So that's why it's called the type. So type here refers to the class, right? So if you say cat c and then c dot get class, it will return the class. Sorry, it will return cat along with, I think, the package details and so on. But yeah, it will return the cat, saying that this is of type cat. So that's all get class does.
So, sir, is it just like basically informing all the methods and like their declare their comments and everything like that? Informing about the object and what instances and everything it has. Or does it return an instance of the class?
If it's about get class, no, it doesn't return the instance, right? It will return the class.
Okay. Okay, sir.
Yeah. Okay, so now, okay, so let's say you have, so we have seen this in the previous lecture, right? So you can use your superclass to refer to the instance of subclass. So since object is the superclass for every class, you can say object O1 equals new cat, because even cat would have inherited from object. And in the second example, you can use object to refer to a string, because string is also a class, and by default it has inherited from object. Right? So you can also have this notation.
So,
Now,
sir, the main class in which we usually code is always a subclass of the object class.
right. So any class that you create it's by default it becomes a subclass of object class. Okay, so let's say you now there could be a question, right? So let's say, for example, in the cat class you have speak method. So now if you want, can we access the speak using object O1? So you have O1 dot speak, and in the second case you have O1 dot toString. So do you think we can do both the method calls?
I think O1.speak will not work.
Right. So why is that the case?
Because it's like this method is hidden for the object class.
Yes, it doesn't have that visibility, right? So object knows only about the methods that are defined as part of the object. So toString is defined as part of the object, so it knows about it, but it doesn't know about all the other methods defined in the cat, right? So speak is one of the methods defined in the cat. So it doesn't know about it, and that's why it's an error. It will give an error. But for toString, it's okay. It knows about toString, so you can make a call to the toString, and that should be okay. So even though this toString is actually overridden in the cat, and it might have provided a better textual representation, right? So it can, that's okay, but it can at least call to still, but it cannot call speak.
So, sir, if we provide a cat reference to this O1 object, then that cat reference can do this dot speak function.
Yeah. If you say cat, say for example, you can say if you say cat C equals new cat, then using C you can call speak and to
No, no,
string
no,
also.
no. Cat C equal to O1 if we do this
The
code.
other way, no, you can't do that, right? You can't assign a superclass instance to a subclass. You can only do it one way, which is you can assign subclass instance to a superclass. Because it is a specialization, right? So this is narrower than object. So object, I mean, the superclass is broader and the
So like we
subclass is
did the
narrower.
typecasting in interface of interface thing that can't be done here.
I did not get it. So
Like
even in the interfaces, you can't say, for example, let's say this is an interface. So you cannot say cat C equals new of transporter.
but you said that we can explicitly convert it back to the instance like transporter object can be converted back to bike object by explicitly converting it.
Because transporter has already been assigned to a bike. So the case there was transporter T equals new bike, and now you are passing the transporter T to as a parameter to, let's say, something like this, to use transportation, which has type bike. So in that case, yes. So since it already holds a bike instance, right? It's a reference to a bike instance. You can typecast it to a bike, and then it should be okay.
So here in void
But you
example
cannot
also if
say.
we do.
But you cannot say bike B equals new transporter. That doesn't work.
So here if in void example we do object other than object O, we write cat O, then can it do, and we pass the object over here.
So in the example here, you are saying here it's cat O. Yeah, you can pass O1. You can, then it might have to
And in the
be
function
typecasted.
example, we can do cat dot O dot speak.
Yes, yeah, you can do that.
Okay. That,
Okay, so now you can have methods which take in object, and as we discussed, so you can also pass cat, but you have to typecast it. And you can also use that in arrays and collections. So you can make an array of object. You can also use, and within this you can place anything, right? Because an array of object, each slot should be of type object, but since object is a superclass for everything, you can have any value there, except of course the data types, basic data types. So you cannot have integer here, because integer does not inherit from object. It's only the user defined data types, right? So, or any class for that matter. So so that's why you can say hello, which is a string, and string inherits from object, and you can say new cat, again cat inherits from object, but you cannot say a of 0 equals 10. That doesn't work. And you can also create a list of objects, and each slot in this array list can be of type object, which means it can take any class, in any instance of any class.
so string is considered as a derived data type.
Yes, because it's a class. So string, when you say string S, it's actually you're creating a instance of string.
Okay.
So it is a class here. Okay, so yeah, this is the next part of the. This is the next topic, right? So I'll briefly introduce that, and then we can discuss the details in next lecture. So let's say you have okay, this is the class point. You have the point class, and it has two values, x and y, or two instance variables. One is called x, and the other one is y. So let's say both are integers, right? And there's a constructor that takes these two arguments, x and y, as the argument. So you are creating P1 and you are passing 5 and 3 to it, and you are creating P2 and you are passing 5 and 3 again to it. So pictorially, you have this box. So since it's a reference, it points to a memory location, which actually stores x and y values. Right? Again, you have P2. Since you said new point, it will create one more memory location, and it has the same x and y values. And now you have P3. P3, you are assigning P2 to P3. That means since you are copying the values of P2 to P3. So the value of P2 is nothing but a reference, memory reference. So that's why since you're copying the reference, both of them point to the same memory location. And okay, so now I can use this. So this is the state, right? So you have P1 with x and y as 5 and 3. This is one memory location. You have P2 which have x and y as 5 and 3. This is a different memory location. And since you assign P2 to P3, the memory locations get assigned to each other. So this also points to the same memory location. So now let's say you do the equality check. So when you do it for, let's say, basic data types, it will check whether the values on both the sides are the same. Right? Let's say you can say 5 double equals 5, which is true. If you say 5 double equals 6, then it will return false. So in this case, if you say P1 double equals P2, it will say false, and for the first two it's false, and for last one it's true. So can you tell me the reason for this one? Why do you get false in the first two cases and true in the third case?
Sir, because when we write point P1 equals to new point, so P1 refers to a object which has the value 5 and 3, and P2 refers to another object which has the value 5 and 3. So P1 and P2 basically refer to two different memory locations. So this equal to sign compares the references which they refer to. So since P1 and P2 refer to two different locations, their equality will be false. Same, now if we talk about P3, so P3 is also a different object, but it points to the same memory location as P2. So that is why P2 equals to P3 is true, because they refer to the same location.
Right. Yeah, that's right. You are right. So since we check the values, and P1, P2, they have different values because they are referring to different references, right? So these two will return false. And since P2 and P3 hold the same reference, this one will return true. But, okay, so there's one more method called equals, which is part of the object class, right? So you have equals as part of it. And now since every class inherits object, it will also inherit all the methods that are part of the object, all the public methods at least. So equals is one of the public methods. And the point of equals is, as mentioned here, so you can call on one object and pass the other object. So it will check whether P1 is equal, whether P1 equals P2. So in the next slide, we'll look at the implementation of equals, how generally equals is implemented. But so far, we got to know that it doesn't work with objects, right? So for example, if you say P1 dot equals of P2, you may want to actually compare the state of the objects, which is 5 and 3 in this case. And both objects have 5, 3, right? So you may have called this method with the intention of computing, or with the intention of checking whether the states are the same, which in this case is true. Both the states are the same, right? But that will not happen, which we will see in a while. Right? So this does not work well with the objects, especially if you want to compare the states, right? So the default method implementation for equals is it simply does the equality check with the double equals operator. So you have return this double equals O. So O is the one that is passed, and yeah, this is it's the instance for the current object, right? So if you are okay with this default implementation, then you can leave it as it is. But if you want to make use of equals and you want to check the equality of the states of the object, then you need to override it. Right? You can, like we discussed earlier, subclasses can inherit from the superclass, and it can also override the methods of the superclass. So you have a chance of redefining these equals and make it suitable for your particular case, right? So in this case, you want to check whether say p1.x is same as p2.x and p1.y is same as p2.y, and that is what you should be checking in the equals. So yeah, so you have to override equals and then give your own implementation for it. So yeah, we'll look at how we do this overriding of equals method in the next lecture. So I'll stop here.